anything. So I don't think the students, young adults, can see the answers that you see. We did these blue ones in bell work, and it's all about what I is, which is what's going to happen today. A lot of big algebra today. So, kapow! Okay, those answers are in blue. Hopefully you can see them. We didn't put them on the board. Okay, but what do you have to do in number 3? What's the word? What's the word of the day? Starts with an F. Come on, period 4. Foil. All right, but then what's I squared? -1, so that you end up getting more than just a foil. You have to incorporate that I squared being -1. We'll have enough foiling today to prove this answer. How about number 4? What do we have to multiply top and bottom by to rationalize that denominator? Yes? 1 plus 5i, and then unfortunately up in the numerator you got a big foil that you have to do and then reduce at the end. 7 just represents a polynomial that when you solve, you get an I number for a solution. That's going to happen today with the quadratic formula. Or maybe it won't. Maybe you'll just get a irrational answer. Got to be prepared for everything. Factoring, I believe this one is unfoilable. So I think most of us in number 6 should have unfoiled. So we will have to know how to factor and hopefully be fast with this. You know what? Just be aware of P over Q. But what can we use in order to help us on P over Q? What did we do yesterday in our notes or 2 days ago? Graphing calculus. Today actually has a lot of concepts that I'm going to pull out of the book, but then I'm just going to give you the shorthand. So don't I kind of like that stuff. And it's not like the book is bad what it says. It's just, I like to make it easier for you. Fundamental theorem of algebra just says this, what I have highlighted in yellow. That the degree of a polynomial actually represents how many complex zeros. By the way, what's the word complex mean? Well, it's right there. Darn it, I forgot. That means both real and what's non-real? Imaginary. So, here we go. So, the fundamental theorem of algebra, the degree equals how many zeros you have in the complex world, which is the only world you know about. Then this is just 100% related to what we just said there. Zeros turn into what? Starts with an F. You turn a zero into what? A factor. So, the degree of a polynomial is equal to the amount of linear factors you can write that polynomial as. So you can write it in factored form. What does linear mean? X to the first, usually a binomial factor. So that's all that says. Then, of course, just a reminder of these synonyms. We just kind of said that in the last one. Zeros turn into what? We just said it. Factors. All right, so today is just a whole bunch of back and forth. He's giving you zeros, and you have to come up with polynomials. Having a polynomial, and you have to find zeros. Or have a polynomial, and you have to put it in factored form. It's all the same situation. Okay, and then the last thing, which is something you need to remember from Algebra 2. It's not only the complex conjugate theorem, I guess that incorporates I numbers, but there's also a radical conjugate theorem, which I'll put up here because it doesn't quite show that here. But look at what it says in there. If I have a polynomial with real coefficients, and I tell you that a plus bi is a 0, then absolutely positively a minus bi must be a 0 as well. Okay, and that's because, think about it. Say you had an x squared with real coefficients. What was the one from the bell work, by the way? X squared what? Help me out. Help me help you. Minus 5x. I'm getting nothing from this hour. Plus what? Thank you. What kind of zeros did I get out of this? Just what kind? Imaginary. And how did they come? What kind of, what did we have in front of in between the imaginary? A plus or minus. So we could see I have a polynomial with real coefficients that when I found the zeros, I got imaginary solutions, and lo and behold, they came in a conjugate pair. So that is where this rule is coming from. The only way you could have a polynomial with real coefficients and having one imaginary zero, there's got to be another conjugate pair. Same thing with radicals. I don't know how to write this. I'd rather not use A and B to confuse you with this one, but If I told you 1 plus root 2 was a 0, and the polynomial had, what do I want to say, rational coefficients, then what else would have to be the case? 1 minus root 2 because of, again, the quadratic formula in reverse. So there's also a radical conjugate theorem if all of the polynomials terms were integers, or rational it could be as well. Okay, let me stop this. I keep losing this. Oh, that didn't stop the movie. Good thing I didn't say anything bad. Okay, you should be able to handle this one without me. So I'm just going to shove the answer in your face after you're done, and then we'll get into more. So own your own notes. Let's Common Core this stuff out. You know, all day in this, we get a lot of examples. So boom! And by the way, do you know who this is? Oh, that's nobody. It's Frozen. See, it's weird. On the movie, I got something, but and here I froze the screen. Boom! Okay? So that's you. Unfortunately, a foil line went right through your face. But anyway, this is you because you have to come up with that other I number because of the complex conjugate theorem. And then when you FOIL x minus I, x plus I, you do end up with x squared plus 1. Here's why. What's negative I times I? Negative I squared. And what does that actually become? Plus 1. And then why do I show these FOIL lines? What happens to these two terms? They cancel, so I don't even have to write them down. So it's x squared minus I squared, which is x squared plus 1. And then you FOIL. Okay? Now I want you to try this one. Oh, yeah. Oh, boy. Is this why second hour got all mad? By the way, at this point, they dropped their calculators about 12 times. And then 3 days. There's a drop. Oh, why don't you? Let's transfer you to second hour because it's hilarious. All right. And then last week, 26 of them coughed because that was, yeah. All right. Yeah. Great. I didn't press tape on all of that I just said. I thought I was taping. Oh, well. Here's the answer. And this is a little thing I just talked about in class. Whoopsie daisies. I don't want to make fourth hour hear that all again. See, I don't hit. Okay. Again, you're going back and forth. The last couple questions where you were given zeros, you came up with polynomials. You got to have your skills of algebra. Now you're given a polynomial. What are you going to find? The zeros. Now it's reverse. Okay, you could do P over Q. I will still ask you that question, how to get the factors of the constant over the factors of the leading coefficient. But also we could go ahead and use our graphing calculator as an aid. And in this one, I don't have to zoom in and actually, actually find the zeros. I can look at that. What does it look like that is right there that I'm pointing at? -1, and what does it look like that one is? 1. But this is what some, and I yelled at second hour for this, because their homework quizzes were not very good. They didn't listen to the number that I told them. You're supposed to not only use the graphing calculator, but then you're supposed to prove it to get the other two zeros. Because there's two other zeros that are not, well, let's just say not rational. So I'll just go ahead and take over the notes from here. Actually, you do it, and then I'll show the answer. Okay, so there's one proved as a 0. I decided to do that one first. Then what you should do next is deal with this depressed polynomial. Look how I write this. I'm going to go ahead and take this depressed polynomial. That column's gone now. Sorry, it's frozen. Not online, though. Okay, so that depressed polynomial, this column's over. This is now an x to the third. And I'm just going to put that right there as a note to self. And then I'm going to prove that -1 works. So this is what you do on these. Now, should have got this. But by the way, there you go. What do the directions say? Write a linear factorization. What does that mean? Write this in factored form. So here's the beginning of it. If 1 is a 0, what is a factor? Now it's a linear factorization. This is a linear factor because it's x to the first. -1's a 0, so what goes here? But then we have this thing, which is an x what now? What is this? An x what? Squared. It's x squared plus x plus 6. Now your world's going to get a little weird. Because it would be nice if I could factor this, then I can write the last two linear factors. Can I? No. If I can't factor, how do I find zeros? Quadratic formula. Negative b plus, you can do the quadratic formula. I'm going to do that offline to keep my movie. This is what's strange. The directions say write a linear factorization, and I have these I number zeros. I don't care. Write it like this. X minus. Actually, I should use brackets. X minus the 0. One of them is negative 1 plus or minus I root 23 all over 2. Oh, actually, I wanted to write one of them. Sorry. I could be kind of lazy, I guess, and do that. But and then X minus negative 1 minus I root 23 all over 2. Okay? And then I think the book does something weird. If I remember the back of the book, they do something that's wrong. How do I know this is kind of okay? Well, the answer to that is this. What's x times x times x times x? What's x times x times x times x? X to the 4th. So I know if I FOIL this as it is, I should get x to the 4th plus x to the 3rd. Make sure you get that leading coefficient. I really disagree with what the book does in the back of the book, I think, as far as these answers are concerned. So be careful on that. Just a note to self. I'm just going to proceed on with this one. Same directions. Okay, and then because of time, I would assume that you know how to type on your calculator. This could be a P over Q, but wouldn't the P over Q be bad? Like 105, 1 and 105, 3 and a number. What number would that be? 35? 3 and 35, and then there may not be much more than that. 15? No. 5 and something. All right, and then all over 1, 2, 3, and 6. Okay, well, let's look at the graph real quick. And then this one, when I look at the graph, I have a problem because the zeros look like they're what? I know I found them, but when you look at them, they're in between two numbers. So they're what? Starts with an F. I have no time for this. Fractions. And then the other one's a fraction. So if you would have P over Q'd, you'd have done all the whole numbers. That's wrong. All the integers. They all would have what? Failed. Then you'd have to go to the fractions. I used to do this back in the day. I know. All right. Well, when we look at this, we see that negative. So we actually have to go in our calculator and find the zeros. And luckily, they are rational. So what are we going to do with this? We are going to synthetically divide and depress with these fractional zeros. And I'm going to do it old school because I know this is going to work. 6, negative 7, negative 1, 67, negative 105. I don't think we need to see all this online. Well, I guess we do. Because this next part just drives me nuts with the students. Drives me nuts. This is probably why second hour hates me. Because a lot of things drove me nuts today. First of all, what do we do first? First things first. Bring down a 6. And then, what's 6 put that calculator down, sir? What's 6 times negative 7/3? How many times does 3 go into 6? How many times does 3 go into 6? Twice. They're not answering anything. What's 2 times negative 7? Negative 14 goes right here, my friends, if I can call you that. What's negative 7 plus negative 14? Negative 21. What's negative 20? How many times does 3 go into negative 21? Negative 7. What's negative 7 times negative 7? 49. I lost my pen. Even the computer's mad at me. How many times does 3 go into 48? Because that's how you do this stuff. What's the answer to that? 3 into 48? 16 times negative 7. Someone give me that. Okay, so it is a 0. Then you synthetically divide by 3/2. This is the kind of question you should be able to do without a graphing calculator at this point. 2 goes into 6 3 times. 3 times 3 is 9. 2 goes into negative 12 negative 6 times. Negative 6 times 3 is negative 18. I hope I don't make a mistake. 2 goes into 30 15 times. Sweet. What's this called now? Depressed polynomial. But you know what? because we synthetically divided by fractions, remember synthetically dividing by fractions created that problem with the coefficients? Anyone? Yeah? A couple remember that? It's not really a big deal. What could I do to start off solving this that makes it a lot easier? Divide by 6. Sorry. Wait, yeah, 6. Never was good at math. And then, there we go. Now, is that factorable, yes or no? I love this day, and everyone seems sad about this. I love algebra parts of our day. I love these kind of things. You all right over there, student number? We'll do this offline. So we finally got the last two zeros. But here's what you're going to do wrong. Maybe. Zeros turn into what? Factors. So you're going to say one of the factors is x plus 7/3. Just give me a minute. Then you're going to say another one is x minus 3/2. Just give me a minute. And then the other one, just because of time, I'm going to be a little bit lazy here. X minus parentheses 1 plus or minus 2i. And I just put both factors together. Now, listen. How come this is wrong? Yes. Yeah. When you FOIL this out, what is the leading coefficient? 1x squared. So what do I have to do with the first one? What is that actually? What should I actually write instead of x plus 7/3? Yes?
3x plus 7.
This has to be 3x plus 7. And then what do I write instead of x minus 3/2?
2x minus.
And then you tack on that last component, and then you're ensured that when you FOIL this, you will get, or cousin of FOIL this, 6x to the 4th as your leading coefficient. What if the other two zeros were imaginary? Would the graphing calculator help you? No, because the graph would never what? Cross the x-axis. What if the other two zeros were irrational? Would the graphing calculator show you the x-intercepts? Yes, but they'd be an ugly, enormous what? Decimal. And you may not be able to think, what is that as an imaginary number? What? An irrational number. I apologize. So what do you think we can do to find the other two zeros?
You know the two zeros that you know, and then
This is interesting. Without the foiling. I like the division. What kind of division? No, I got you. I know what you're talking about. Wow, that's genius, but that would take longer than what I'm going to do. He wanted to take these two and turn them into factors and then multiply them out and then long divide this one by that other polynomial. That would work. But I got a better way. There's another type of division. Okay, synthetic division. If anyone whines, I swear to gosh, I'm transferring you to the second hour. Then I'll deal with all my whiners together. Ooh. 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 Oh, yeah. Not whiners, but I hear some stories, fourth hour sharing about how unpopular Mr. Samuelis is right now. So, that's fine. No whining on this. Because watch the first thing. What do you do first? And by the way, what should happen at the end? Zero. They're telling you this is a zero if you had a chance to read the directions. Let's find out. What do you do first? Bring down the 1. And then what? Well, that's easy. So you multiply. This is why I left so much space. And then how do you add these two? You just add the real components is how you would verbalize that. Oh, okay. Now this is the first time something challenging happens. All right. I'm going to put my work off to the side here, and I would suggest you do the same. If I stole your graphing calculators on this question, which I probably will, because you know you can type this on your calculator, don't you? You know you could type this on your calculator and just press enter and be a button push and screen copying person. Not doing any math at all. By the way, this is kind of conjugate-ish, if I could make up a word. Just watch what happens to the middle terms. What happens to the middle terms? They cancel, so that's all I really care about is the first and the last. What's negative 9 plus 4i squared? Negative 13. Boom. That became easy. All right, and then this becomes negative 2. And then guess what I only have? I just have a distribution, and I think I could do that without writing it out. Negative 2 gets distributed into this. I think I did something wrong. Hold on. I didn't do anything wrong. I never do anything wrong. 6 plus 4i. All right, and then I need a spot to do this one. Maybe I'll write it and then I'll erase it, because there's a reason I'm doing what I'm doing. All right, so 3 minus 2i times 6 plus 4i. So this is only the second time we had the FOIL. 18. Hey, look at the middle term again. What do you notice about the middle term? They cancel. So I'm not even going to write it again. What's negative 8i squared, everybody? 8 plus 18 is? Boom, shaka. Anyone? Okay, and then before we start whining, oh, we got to do that again. Watch how easy the next step is. What else is a 0? What else is a 0? Watch how simple that. Bless you, my friend. This is a very what? Depressed polynomial. Bring down the 1, but watch this. 1 times this is this. What does this become? 0. Oh, look at that. Oh, look at this. Distributes. And did it happen? Yes. And then what is this called? And it's not so depressed. And actually on your graphing calculator you might have been able to figure out these zeros, because some people do know what the square root of 2 is. What is the square root of 2? Anyone know? 1.41, and if you would have saw that, you might have recognized that root 2 and negative root 2. But I swear to gosh, I have a test question where all 4 zeros are imaginary. So will the graphing calculator even help you? No, so you have to go through this process. By the way, this was find all the zeros and write a linear factorization. So, all the zeros are these. Linear factorization is quite simply x minus all those zeros. I'm not writing it. When you have an I number 0, that's a plus bi, just put it in parentheses. You understand what I'm saying, like I did before in the earlier questions? And I think I'm done. No, I'm not. One more. Last one. Okay, degree 4. Let's just get this over with right now. F of x equals a x minus z, x minus z. Notice what I'm putting on the z's though. X minus z. What do you think z stands for? X minus z, huh? 0. The zeros are... Ah! Ah! That sounded like Chewbacca. All right, so, by the way, your brain says also what is a 0? 2 plus I. Okay, so that's what I'm going to put in for here. Hey, what's that other thing at the end? F of 0 equals, doesn't have to be, it is the y-intercept. It doesn't, it could be f of whatever equals whatever. This is just another what? Points. What is 0 going to go in for? No, yes, sorry. And then what's 30 going to go in for? Y. So, now we can put all this stuff in and actually see how easy this question is. A is the only unknown element. Wherever there's an x, I'm going to put 0 in just because this, again, this didn't have to say f of 0. It could have said f of 12 equals 3. Then 12 would go in for x and 3 would go in for y. All right, and then what's the other one? Minus a negative 1. We can handle that later. And then this actually is not bad. All you have to do is distributes that minus sign in these. And then really what it comes down to is, you know this, heck, I'm just going to finish it off. 30 equals a times negative 3 times 1 times, you know what? I'm going to go ahead and write this as negative 2 plus I. And this as negative 2 minus I. And then the next step will be, what does that become as a number that is real? And the answer to that is 4 minus I squared. What is 4 minus I squared? 4 minus I squared is what? 5. This is negative 15. 30 divided by negative 15 is negative 2. Then I'll tell you how you write your final answer. Just put negative 2 in for A, and then plug the zeros back in, and you're done. Leave it in factored form. Got it? The early assignment is enough foiling. This last number, which is I think number 50 in the homework, leave it in factored form. What we're trying to get is that A value, though. And this is how you do it real fast. Really just some more multiplying. All right. So good luck with that assignment. It is a little bit lengthy. This might be a working night.